Alright, so we're doing section 6.5. This is drawing transformations. This is pretty straightforward, and you should be able to draw transform figure when given a sequence of transformations with either a written description or an algebraic description. Okay, so here, whoops, bumped the camera. So here we have a polygon of M, polygon MTWP, and the first transformation is reflected over the XY axis. Okay, reflections are pretty easy. If you need to do a coordinate pair table, the XY comparison for the X for reflection across the y-axis is x, y. The x-coordinate flops, the y-coordinate stays the same. Alright, so it's y negative x, but you really don't need to if you understand what reflection actually is across the y-axis. So point M here is going to stay the same for the y variable, and it's going to flop for the x variable. So it's going to go from negative 4 to 4, but it's going to stay 12 for the y variable. So that's going to be M prime. Okay, P is going to stay 8 on the y-axis, but it's going to go from negative 8 to positive 8. So it's going to ride this 8 from 8 to negative 8, or from negative 8 to 8, and that's going to become P prime. And then it's going to go from negative 4 to 4 on y equals 4. That's going to be T prime. And then on x equals, or on y equals 0, it's going to go from x equals 12, negative 12 to x equals 12. So that's going to be W. Right, so here are our after that initial first move, it's going to look like this. Okay, so there's our polygon after our first move. Okay, just a little bit, missed a little bit here. I'll redo that. Okay, there we go. All right, so there's our first polygon, and that's W prime. All right, so these are all prime values. All right, so then their next one, the next one is going to be, we're gonna shrink this, dilate it by point C by a scale factor. Point C is going to be our dilation point. Point C is going to be our dilation point of a scale factor of 1/4. So our coordinate pair comparison would be 1/4 x, comma 1/4 y. Right, so our x value for M is going to be 1. So it'll be M prime is going to be right there. And our 1/4 value is going to be 1/4, or 12 divided by 4 is going to be 3. So our M value is going to be right there. It's going to be M double prime. Okay. Then our T value is going to be 1/4 of 4, and then 1/4 of 4, so it's going to be right there. So it's going to be T double prime. T double prime. Alright, then our W, it's at 12. 12 divided by 4 is 3. So that's our W value, and it's on 0, so it'll be our W value. Right, and then P is 8, 1/4, that's on both sides. 1/4 of 8 is going to be 4, or 2, sorry, 2. So this itty bitty tiny little polygon. Tiny little polygon. Oh, that's not it. It's this one. It's hard to tell my dots from my slashes here. This go from 12 to 4. Yeah. Is that what it was? 12 to 3. Yeah, that's 12 to 2 to 3. Hard to draw. 2 to 3. And then from here to here. And overlay that. Alright, so that's my tiny little smudge of a polygon. Let's see if I can do that better without marking stuff. Okay. So let's just do, alright, 12. That's 12 times 1/4 is 3. So it's going to be over here. And then 1/4, that's going to be 1 and 3. Okay, that's just that dot. Let's smudged it. Alright, then we have 4 and 4. 1/4 of that is 1 and 1. It's going to be along the line. That's 12. That's going to be 3 and 0. And then this will be 8 and 8. That'll be 2 and 2. Okay, let's try that a little bit tinier. Make it more crisp. Need like a super fine pen for this. If I give you guys this one, I'll give you bigger paper. Move that over a little bit. Count for the width of my pen tip. And there we go. There, it's tiny. Tiny polygon. Okay, so that's my dilation. 1/4 to 1/4. That was interesting. Alright, so moving on to this one over here. I'll do the bottom one, so I don't have to deal with lifting up this camera after this one. Alright, so this one is given in a different, in like paragraphical form here. Alright, so it's telling us to, there we go. Still getting used to this tiny paper. It's all on one paper. I don't know why I try to do it all on one paper. Save the planet stuff. Okay. Alright, so I'm gonna plot double prime of this object. Okay? This is my pre-image, and I'm gonna do 2 dilations, right? I'm gonna do, 2 transformations. The first, a 3/4 dilation at point F. So this is my point of dilation, right? Not the origin, right? Point of dilation is gonna be point F. Okay, so I have to do a little bit of critical thinking here. Okay, then rotating it at 90 degrees. All right, so I'm not dilating it at it from each point from the distance of the origin. I'm dilating it from the distance of point F. All right, so I just have to figure out what the distances are. This is kind of going back to our first one. All right, so 3/4. Okay, so 3/4. So what is my F value? So from my distance of h, I'm just going to do my distance of h, my x and my y deltas. Okay. Well, from my x, there's no difference in x. Right? It's just a simple. My difference in x is 0. Okay. My difference in x is 0. Right, this is deltas. Right, my difference in x is 0. My difference in y is -12 minus 8. -12 minus 8. My difference is 20. All right, so there's 20 blocks between here and there. I just did it the quick way. I could count it by going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And each one of these blocks is 2, so that's 20. Okay, so I just did it by negative 12 minus positive 8 is 20. Or you could do 8 minus negative 12 is 20. Either way, it's 20, right? So I'm dilating it by a factor of 3/4, which means I'm going to make it smaller, right? So I'm going to take 20, right? I'm going to multiply it by 3, and then divide it by 4. That means it's going to be 15. So my new spot for my h prime is going to be 15 distance from this, right? So it's going to be 15 minus, it's going to be 8 minus 15. 8 minus 15. Right, so it's going to be negative 7. Negative 7. Okay, so if I look at, double check this, I can make sure that this is 3/4 the way to here. Right, so if I wanted to double check that to make sure I was right, I go negative 7, 7 negative, minus 8 is 15, right? And that's 20 divided by 20, and that's 0.75, okay? That's that 0.75 of the distance of there. All right, so that is my h prime. H prime, that's my distance from there to there. Okay, now I need a third the distance from here. Okay, so this is a negative 7 point, yeah, that's 7. My new x value is going to be, my change is going to be 7. Okay, this is the change in x as relative to f. All right, so now this one is going to be pretty easy. It's 3/4 of the distance for my x value and my y value. Okay, I need to figure out what 3/4 of the distance of this is. Okay, so my 3/4 of the distance, I'm going to figure out my change in, so this is my f to w. This is for f to w. This is f to w, right? So f to w, my x value change is 1, 2, 3, 4. Like 4 times 2 is 8. Or I could do 12 minus 4 equals 8. Right? So 12 minus 4, that was 8. Okay. So I need 3/4 of 8. So 8 times 3 equals, divided by 4 equals 6. All right, so my value for here should be 6 away from f, right? So 6 plus 4 equals 10, right? So my f value is 4. I need to go 6 from that, so it should be at 10, right? So it's going to be right there. Right, because it's a proportional change between, I only need one of those. Right, so this is going to be my new w value. Okay, now my next one is going to be my b value. Right, now my b value is going to be a little bit more challenging to determine, because it's going to be a factor of both my x and my y. I need to do both of them. Okay, because it's not connected directly to f. Okay, so it actually have to figure out my difference of both. Okay, so now I'm going to have to do my change in x and my change in y to figure out where in here somewhere I have to plot that dot. Okay, and if I look at this here, you can see it's going to be somewhere along that line there. Okay, so my change in x value from 20 to 4 is 16, right? And then 3/4 of 16, 3/4 of 16 is 12, right? So my 12 value, so my x value for b is going to be 12. Right? Now I got to figure out my y value. my y value is going to be, so I started at -8, right? And I went to 8. So -8 minus 8 equals 16. That's 16 units, right? So 16 units times 3/4. Remember when you have the word of, right? Like 3/4 of something, it's multiplication. 3/4 of is 12, right? So my it's gonna my b is gonna be 12 away from f on the x direction too, right? So this is all relative to f. F is my new origin, right? So it's going to be 12 from f. So f plus 12 is going to be 16 in the x direction, x plus 12 in the y direction, or f minus 12 in the y direction. So 8 minus 12 in the y direction is going to be -4, right? So it should lie on right there, right? So that's my new B point, right? So that one is a little bit more tricky, but there you go. I have it now. It's now all done up. A little bit trickier, and the only reason that's trickier is because I need to calculate the new distances from my point of dilation, which is not the origin, because all of these numbers here are relative to my point of origin. When I'm changing my point of dilation, f now becomes my new point of origin relative to this dilation, right? So I have to like kind of adjust everything for that. I might have to show you guys that in class again. All right, so that is my new smaller shrunk f prime, or polygon prime, if you will. Okay, now the next thing is pretty easy. I'm just going to rotate this thing to my orange image. My double prime image is going to be my orange image. So a rotation of, what does it say? A clockwise rotation, my clockwise coordinate pair. Remember, y comma x is when it's a 90-degree rotation. The x is and the y is flop. When I'm rotating it clockwise, it goes zippy out a little bit. Zip out. Clockwise rotation, when it goes this way, like clockwise, you have to put the negative sign in front of the x because it pushes it that way, right? If you're gonna do counterclockwise, the x nudges it. The negative sign goes in front of the y. It goes that way, but the x makes it go that way. It's just an easy way to remember clockwise and counterclockwise, at least for me. All right, so I'm going to do a point comparison here because it's easiest for me to do point comparisons. So I am going to do, for my point comparisons, I'm going to do a f prime, a w prime, a b prime, and an h prime. I'm going to pull those points up. It's going to be 4, 8, 4, 8. And it's going to be 12 and 4. 12, 4. Then it's going to be -4, 16, -4 and 16. And then h is going to be 4 and... Nope, that's not right. It's not -4 and 16. B was 16 and -4. B was 16 and -4. Okay, and then it's going to be, h is going to be 2, 4, and -7. 4 and -7. Okay, so now I'm going to apply this point comparison to that. So y comma -x is going to be my new xy coordinates. All right, so I'm just going to pull the x. It's going to be my new xy coordinates. Is my purple y -x. Let me clean this up a little bit to make it clearer. It's going to be negative, nope, it's going to be x, nope, let me go back there. It's going to be a y, negative x. So my new x and y coordinates, my new x coordinates are going to be the old y's, so 8, 4, -4, and -7, and my new y coordinates are all positive. They're going to turn into negative. They're going to be my old x coordinates, but they're going to be flop from positive to negative. That's what the negative sign means. All right, so -4, -12, -16, -4. So now I'm going to take these and I'm going to plot them. 8, and 8, and -4 for my f point, f prime, double prime. These are all single primes. I don't know why I wrote single primes. Let me zoom in a little now. Okay, and then I had 4, -12. 4 and -12. That was w double prime. Then I had -4, -4, -16. -4, -16 is way down here. That is b double prime. And then I had -7, which is right here, and -4, which is right here. That would be h double prime. Connect those together. And let's see if I made a mistake somewhere. No, it looks like it is right. Okay, so that's how you do that one there. Okay, because this one here just kind of rotated about the origin. So if I took like f, let me take a different color here. Maybe a blue. I haven't used blue here. And I did a 90-degree rotation. I went to the origin. And I went to the origin. I rotated each one of these points 90 degrees at the origin. Right, each one of those is a 90-degree clockwise rotation. W. If I had colors would be better, but you see W here, W prime. W prime. Alright, and then we got probably just make it more confusing. We got B prime. It's 90 degrees. That's 90 degrees. Alright, you can see how all those are 90 degrees there. And even H. It's just getting messy now. Okay, anyway. So moving on to this one. Alright, so this one has this little baby triangle here. We're going to translate it, and then we are going to dilate it by a factor of 3. So my initial translation is going to be purple, and I'm going to do it with point comparison. I'm going to do G, Y, W. Initial points are, looks like 1, 3. Y is 6, 5. And W is 7, 1. All right. so my what I'm going to do to dilate this, or not to dilate, but to translate this, is I'm gonna do -4 and -1 to get my new xy's. I don't know why I drew a line right there. Okay, so that should be 1 minus 4 is -3, 1 minus 6 is 2, and 6 minus 4 is 2, and 7 minus 4 is 3. So -3, 2, and okay. And then 3 minus 1 is 2, 5 minus 1 is 4, and 1 minus 1 is 0. Alright, so I'll take that and I'll plot all of those. So 3 and 0. 3, 0, this is my new W point. I got maybe go in on this a little bit. That's my new W point. Alright, my new W point. Right, so, and then I have y is 2 and 4. Y is 2 and 4. 2 and 4 is my new y point. And then g is going to be way over here at -3 and -3, -3 and 2, -3 and 2, -3 and 2, right there. Okay, so I'll draw those guys. There we go. That is W prime, Y prime, and G prime. Right there. Alright. Now, the next one is going to be to, so this is a dilation of scale factor of 3. So this is a scale factor of 3. So that means every one of these is going to be multiplied by, all of these is going to be multiplied by 3. So that's going to be -9, -6, and, or no, not -6, it's going to be 6. 6 and 9. And this one is going to be, let's see, 6, 12, and 0. So these are going to be my new points here. All right, so let's go -6, or -9, which is going to be here, and 6, it's going to be here. So it's going to be right there. That's my new G prime, G double prime. Okay, and then I'm going to have 6 and 12. That's this one. That's my new Y prime, double prime. Then I'm going to have 9 and 0. And that's that one, right? So this one kind of like expanded out from the center of the origin, which is kind of neat. I thought that's pretty neat. Alright, so this guy expanded like this, because it's kind of like spread out at the origin there. It's at the origin, right? I'm presuming it's the origin. It doesn't say, so I kind of presume it's at the origin. And that looks pretty cool, because it's we have 3 different points, kind of like in, like 2 are in a different coordinate plane, and then one's just resting on the x-axis. So it's kind of neat to see how that kind of behaves when it expands. And again, you can double check all that by tracing the points that you expanded to their point of dilation, and where they intersect is their point of dilation, is the point of dilation. And if you were to measure the distance between here and here, and then here and here, and you divided this by this, you would find that that was 3. That's the scale factor of 3. Pretty cool. I think it's cool. All right, last one. We'll be done in 35 minutes, I think. All right, so we have our orange one, final one, is the result of a reflection. That's our first one is going to be a reflection. And then translation. Ooh, this is 4. Cool. And a translation. Then it's going to be dilated. Sweet. All right, so maybe this will take 7 minutes. All right, so the first one, it's going to be a reflection. Reflections are easy. We just take this guy. It's going to be a reflection across the x-axis. Reflection, the first coordinate comparison is going to be x comma y. Reflection across the x's, so the y's change state, right? So it's going to ride 1 to 3, from -3 to 3. It's going to ride 3 from z. It's going to ride 3 from -1 to 1, and f is going to ride 5 from -4 to 4. So those are our primes. I'm just not labeling them for the sake of space conservation. Alright, so you can see that. So that kind of all went together there. Let me see how the distance between each point is the same from the point of reflection. And the distance to the y-axis is the same. That's how you know you did it right. I said point of reflection, I meant line of reflection. Sorry about that. Okie dokie, now that one is all done now. Okay, so that is our new prime. This is after our first transformation. Okay, and those are our primes. So that's our prime triangle. All right, so now we're going to translate it 3 over and 3 down. Well, so I guess we probably should pull some coordinate points off. So we'll just do a B, Z, F. Our initial point for B was -1, -3, 3, -1, and then 5, -5. Then we did this, so the x values all stayed the same, 1, 3, and 5. The y values all changed to 3, 1, and 5. The negatives dropped off that. Okay, so that is after transformation number 1. Okay, now we're going to do transformation number 2. Transformation number 2 is a translation to 3 units up and 3 units left. Left is minus 3x, and then our delta y is 3 units down, so it's going to be minus 3. Okay, so this is transformation number 2. And you can't see what I'm doing. Here we go. Sorry about that. Alright, so now I'm going to take each one of these. I'm just going to do some simple math. Excuse me. All right, so negative 1 minus negative 3 is negative 2. 3 minus negative 3 is 0. 5 minus negative 3 is negative 2. 3 minus negative 3 is 0. 1 minus negative 3 is negative 2. 5 minus negative 3 is negative 2. Okay, so this is my new point comparison, my new points for my new polygon. So we'll zoom back in and plot them. All right, so negative 3, negative 3. Right here. Is that right? No, I was right. I was reading the point comparison. Negative 2, 0, negative 2 and 0. Negative 2 and 0. Negative 2 and 0. That's my first one. That is my second prime. Okay, for B. All right. That's why I kind of keep this table. It's handy to keep track of all the points too. All right, then my my z value is going to be 0 and negative 2. 0 and negative 2. Okay, that's going to be my prime, double prime for that point. Okay, and then I'm going to have negative 2 and negative 2 for my F point. Negative 2 and negative 2, negative 2 and negative 2. And there's an error somewhere, I believe. Let me double check. That is correct. Let's see, that is correct. That is correct. That is correct. 1 minus 3 is negative 2. 3 minus 3 is 0. 5 minus 3 is not negative 2, it's 2. Okay, so my first point there. Check all my maths again. 5 minus 3 is 2. Okay, then 0. Negative 2 and 5. Okay, yeah, I plotted points wrong and everything too. Okay. All right, so negative 2. All right, so we got negative 2 and 0. Negative 2 and 0. Here's my prime point, double prime point. Then we have 0 and negative 2. 0 and negative 2 is this one. And then we have 2 and 2 right in the middle of that. 2 and 2. Negative 2 and 0. 0 and that's not 0 and negative 2. This is 0 and negative 2. Man, it's getting long. Negative 2 and 0. 0 and negative 2. There we go. Man, this is a long. Whew. All right. That looks better. This is a long. Yeah, that makes more sense. This is negative 3, negative 3. It should be back down. And it should look like right back by the same value. Man, this is a long lesson. All right. This is number 2. There we go. See, I struggle with that one as well. I don't know why. Probably because it's a long lesson. All right, and then finally we have a scale factor of 5 halves at point Z prime. Point Z double prime. So point Z double prime was the 0, negative 2. This is my point. This is my point of dilation right here. All right, so here I have to figure out what the distance between all of these are to dilate them. So for this one, Z is going to be easy. Z is going to be my point of dilation, so I'm not going to have to dilate that by itself because I don't have to dilate it, right? Because it's going to stay there. My point of dilation, the distance is going to change at all. Okay, but I'm going to be 5 halves. 5 halves is bigger than 1, so this is going to be an expansion of this. Okay, so my distance between my y value, my x value distance between this point and this point, right? This is a -1. This was let's see, -2. This is my b prime. That's my b, right? And this would make this my f, right? So to expand this z to z prime, or the z prime double prime, the z prime to z. Oh, sorry, I guess z double prime to z triple prime, right? By a scale factor of 5/2, I need to do both the x value and the y value by 5/2, right? So this is -2 and 0, right? So this is -2, this is 0, -2. So my x value distance is -2 minus 0 is 2, right? I'm going to multiply that by 5/2. So that my new x value is going to be 5. Right? Now my y value is still 2 away. Right? So I'm going to go 0 minus 2. Its distance is 2. Right? Absolute value is really not that much of a big deal. Right? 5/2 times 2 equals 5. So now it's going to be 5 away. Right? So it's going to be 1, 2. It's going to be 5 away from 2. So 5 away from -2 is 3. Right? So now where these two intersect is where my b quadruple prime is going to be. And you can see that it just continues that straight line. And I got like a nice 1-to-1 ratio here of these blocks. Right, it just splits these blocks right down the middle. I have 3, and then 2, so it's 5/2. So total of 3, 5 total. 5 divided by 2 is 5/2. So that's convenient, easy way to measure that. Okay, and this one, my change in x is 2. It's 1 to 2, right? So that's again going to be 5/2 times 2. So it's going to be 5 difference in the x direction. So it's going to be 5 here. And then it's 2 up. So my distance between 2 and negative is 4. So 4 times 5/2 equals 10. So it's going to be 10 from -2. So that's going to be 8. Alright, so 5 and 8 meet. And that should line up. And it does. So I want to do that. Those two triangles, that should all meet up like that. So that is my B. This was my F prime. F double prime. Alright, so there we go. That is how, well, you can't see any of that stuff. You can't see the grand finale. Alright, so there you go. That's how it all worked out. Now, so if you take, I only had 2 really to go, so if I've intersected all with the point of origin. So since I had only 2 points to run together, it made a triangle. It's pretty simple to do. Alright, so that was fun. That was 45 minutes. Holy cow. That took a lot longer than I thought it would. I hope that you guys gained some from this. Those last couple were pretty challenging.
and after today, we'll give you some more practice on drawing these, and we got one more, and then a couple for the honors folks, and then we'll have our first halfway unit exam. This unit 6 is a little special in that it has 2 exams, so this should be a good one.